I'm Jonathan from Developing Mathematical Thinking Institute, and I'm going to walk you through quadrilaterals today. So how do we construct them? So here I have 4 coffee stir sticks. They work pretty well at representing lines. So I'm going to move them away for a second. And we're going to start with one line here. So a quadrilateral is 4 different lines that intersect. So we're just going to drop these so that all the lines intersect. So we have 4 intersections. We have a closed figure, straight lines, and this is called a quadrilateral. Now we can be more specific. I might say, what if I had one set of parallel lines? So I can maneuver these anyway so that they're parallel. And then I'm going to take the other 2 lines and I'm just going to drop them anywhere. And that creates a trapezoid. At least one set of parallel lines. Now I can maneuver these a little bit as well. I can say, well, what if there was a right angle here? This is a right angled trapezoid. What if I put them so that these angles here, you can almost see how these line up to be an isosceles triangle, and this is actually called an isosceles trapezoid. But what's nice about this is you can, as long as these 2 lines, you might want to tape these down, but as long as this is parallel, that's a trapezoid, that's a trapezoid, that's a trapezoid. But if you notice at one specific place here, that these 2 lines also are parallel, when you have 2 sets of parallel lines, then you have a parallelogram. So this is a parallelogram. You could have students draw this, and you can maneuver it in. You could get a really skinny one over here, really long parallelogram, so you can see kind of all these are parallels. But at this one moment right here, you might notice there's another constraint happening. Here, I have 2 sets of parallel lines, and now, pretty close, if all of these line segments are congruent, the same length, I have a rhombus. So it's even more constrained here. Now I could also pull these up and say, well, okay, I want a parallelogram. So I have one set of parallel, but then if I take another set of parallel lines and I drop them somewhere, but now the angles are all 90 degrees. Now I've constructed a rectangle. So 2 sets of parallel lines, so it's still a parallelogram, but it's more constrained because it has 90-degree angles, so it becomes a rectangle. If I scoot these in so that all the line segments are congruent and 90 degrees, now I've created a square. So a square still is a trapezoid, at least one set. It's a parallelogram, 2 sets. So a rectangle because it has 90-degree angles, and it is 4 congruent, so it's also a rhombus and a square. So it has the most specific of all the names. Now, there are a couple more shapes that you could create. There's one that people call a diamond, which there is no shape called a diamond. And now we can construct another shape, which is called a kite. I'm going to construct where these adjacent line segments are congruent, the same length, and these are the same length, but not all 4 are. Then that becomes a kite. So you can kind of see, I can maneuver those around. That's still a kite, that's still a kite. If I maneuver those here, that's still a kite, still a kite. That's not a kite, it's now a triangle, but I can invert that too, and that is still a kite where these adjacent line segments are the same, and these 2 adjacent line segments are the same as well. So that gives you the 7 different shapes, or quadrilaterals.